ready to go. You ready?
Yeah, I'm ready.
1, 2, 3, go.
Yeah, this slide has been on there already for 2 minutes, so it's a spoiler. My name is Aram Bartol. I'm a Berlin-based artist. I started the Dead Drops project a year ago, a little bit more than a year ago in New York City, where I was artist in residence at the Media Art Institute IBEAM. The first Dead Drop I did together with my friend Bree at the New York Resistor MakerBot location in Brooklyn. It's all about sharing files offline. I also assume that a lot of you have seen that project online, so it's more like a wrap-up talk of what happened over the year. It's about sharing files offline. You can make your own Dead Drop in any place you want. It's just a USB flash drive you cement into a wall in the city. It's, of course, there's no internet, so there's no IP number, there's no tracking. It's about having fun with files and be anonymous. So there's a whole website around it. You can make your own Dead Drop and submit it to the Dead Drop database. This screenshot is like a couple weeks ago. Maybe now it's 800 Dead Drops. I don't know what it says, 738. So there's been around 750 Dead Drops been made since last November 2010. I'm pretty sure not all of them are existing still, but it's an ongoing sort of self-running worldwide. I consider it as an art project, but it's also very useful. Many people have done it in different locations. There's always the 3 pictures like showing the location where it is, like the information. When you scroll down, what you don't see here, then there's the OpenStreetMap location, and also there's information what people put, not what they put on the Dead Drop, because you should not tell online what you put on the Dead Drop, right? So, and then there's many people doing like spin-off ideas. It goes different directions. Here, these guys, like they soldered the LED out there to the brick wall. There's also wireless drops, so you can submit Dead Drops in different types of Dead Drops. I also, we implemented doing live drops, which is actually file sharing party. Not many people use that, but this is, the wireless Dead Drop, which is also useful. There's other people like David Darts. He does the Pirate Box you might have seen online. It's like a, software. It's a server running on a router box and all that stuff. It's interesting to look into that. Of course, I also assume there's many people here who do or have done geocaching. Of course, there's some correlation to that. It's interesting to look back in the history of letterboxing. I mean, on one hand, Dead Drops is the spy game, right? So I hide something and something else, the other spy picks it up. But on the other hand, there's the whole idea of letterboxing, which is from mid-19th century, coming from UK. So you have walks in the nature, you find something in a box, you put your stamp in your book, etc. So there's a whole interesting history about it. The Dead Drops world map is also improved since there's different people helping on the project, programming apps. There's an open API. There's recently Digital Overdose translated the whole Google Maps thing to OpenStreetMaps, which is great. People use Dead Drops for all kinds of fun experiments. So people done art shows here in France, art show on Dead Drops in the city. So people go and look at files. Also, bands release their music on it, or you find all kinds of interesting files on Dead Drops. This is the current Berlin map. We still need to implement if a Dead Drop is still in function or not. This is sort of missing at this stage. This is the submit form where you can upload all your stuff. There's the drop types you can't see now, but it's wireless drops, it's live drops, it's USB flash drops, and there's also somebody, and then there's other, when somebody just installed SD card reader somewhere. It was in a show at the MoMA in New York City this summer, fall, called Talk to Me, like a interaction design show, and people could drop their art in the dead drop in the MoMA. So I encouraged everybody to go there and put because all the artists want to be in the MoMA at some point. So go there and drop your art on the dead drop in the MoMA so you can claim you have art in the MoMA. What people did, and they just sent me back the 5 dead drops which are in the show, so that was kind of funny to go through them and to see what's on there. Yeah, this was just recently the iPhone app came out. There's also an Android app, and yeah, I will show later. There was lots of press over the last 12 months, 14 months. Interviews, things going on. People, journalists especially, keep asking so what's on them? And I keep telling them yeah, well, I don't know. You have to go and check them yourselves. And that's the whole point. I mean, so people mostly don't, or you always need to explain, no, I didn't do the 700 dead drops. It's people out there in the world did them. And I only saw maybe 20 or 30 when I go to a city. Time to time I check them. Yeah, this is the people who worked on it. I'm very grateful for all the team members here doing work over the years. Yeah, there's an Android app. There's different HTML5 mobile page stuff going on. Bruce Sterling did with his class the whole thing to layer to the augmented reality browser. So, as I said, it's if you're interested to work with the API and stuff, you're invited.
All right. Oh, sorry. That was the first Pecha Kucha round presentation ever at a Congress. Give him a huge round of applause. That was awesome. That was amazing. And also, all of the slides are going to be posted online afterwards. Mind hacking, are you here? Yeah. Okay, cool. No, some of the presenters scheduled Q&A time in their slides, so it'll be obvious when they.
Okay, is this working? Are you hearing me? Okay, it's in the back. All right, great.
So it'll be obvious.
That isn't my first slide, actually, Nick.
It isn't?
No, that is it.
Okay.
Yeah.
All right, cool.
Right.
So, yeah, and some of the presenters have it in them. Could we bring this mic down just a little bit? Or no, the podium mic. Yeah, because sometimes if I cough or something, it's picking it up. So, you ready? Okay.
Yep.
Go.
Okay. Hi, everybody. I'm Eulenher, and when I'm grown up, I'm going to be a mind security expert, I guess, because what I'm interested in is mind hacking, how our minds can be hacked, how they are vulnerable to hacks, what attacks can be carried out on minds, and what can be done on this. So this is about hacking minds, not computers, because somehow minds are like computers, you know this, and what's like a computer can be hacked actually, and we can hack things. We can find out where they're vulnerable, and I'm telling you a little story on this. I'm telling you a story from Dan Dennett about ants. And there's this ant which walks up a blade of grass, and it walks up and it falls down, and it walks up again, it falls down again. And what's in it for the ant? Why does it do this? Why would it walk up that way? Well, actually, it's not an ant, it's an SUV for a parasite that's nested in the ant's brain and drives it up the blade of grass. And it's not the ant that's controlling this. And the question is, of course, can this happen to humans as well? Can this happen to us? How can this happen to us? And of course, it's not the parasite in this case of humans, it's ideas that hack us. And I really don't like to be an SUV for an idea that I'm not aware of, and I really don't like to be hacked and not aware of it. I don't want to be driven in a wall by some idea just because I don't know it, and just because I was hacked, of course. And And have you ever participated in a shouting match where what was more important to win than to convince? That happened to you? I guess it did, because this is how we sometimes do discussions. And the problem with this is, of course, you don't convince people of your point of view by telling them that they're wrong. You never attack a system where the other side expects you to attack. You have to do something else to hack somebody. You have to go inside. You have to understand them and get inside the system, and then you can hack it. That's how you do a hack. You don't attack where it's expected. And the problem, of course, is that when we are in a discussion, the other side doesn't see itself as being wrong. Nobody sees an idiot in the mirror. Nobody sees somebody in the mirror that is wrong. Nobody sees himself that way. So if we want to hack people, if we want to convince people, we need to do something else. We need to do more than just telling them. Some people should see an idiot in the mirror, I think. And how do we do that? Yeah, we don't do that by telling them they're an idiot, because then we're building enemy lines and we have the point of view of an enemy towards us, and we can't do anything. So we have to do it another way. We have to hack them like a hacker does in a real attack scenario. We have to do it right. We have to find the vulnerability and do it that way. And this is a big question, because it's not easy, of course, to hack people, because a brain is much more complex than a normal computer, because it's a black box. We have some inputs, the brain has a state that we don't know, and some outputs. But we don't really know what happens in between. And where would you turn to find out more about this black box? And this is what we like to do. We turn to science, of course, because there are many scientists who manipulate inputs towards brains and figure out what's happening and figure out what outputs come out on the other side. And science is the place to go. There's a lot out there, but the problem is it looks like this. It's more like books and publications, and it's not easily accessible to us to find out how are we vulnerable, what attack scenarios are possible, what hacks are possible. And we don't like this, actually. So we started this project, mindhacking.org, and we want to build a site. We want to build a website that easily and accessibly provides people with the vulnerabilities of their minds and how the minds can be attacked and how they can protect themselves against them. And of course, we want to hack people. So this is a call for participation. We are 2 at the moment, 2 of us, and we'd like to have many more of you, because all of you in this room here are much more, you know much more than the 2 of us do, and we'd like you to participate in this. So we need 2 kinds of people to help us out. We need researchers. We need people who help us go through this scientific material, figure out what hacks are in there, get them out, and provide them in an accessible manner for people on our website, and aggregate the information in a way that actually helps us to understand it easier and understand the vulnerabilities that actually are there. And of course, we need developers. We need to make the site in a way that is accessible to people, that is simple to use, and an interface that is simple to use for people, so they can actually be informed that way. Because we believe that in educating people about the vulnerabilities of our minds and how they can be hacked, we can inoculate them against that, and we can give control over our ideas a little bit back to people. We want not to become SUVs, we want to be in control ourselves, what we like to do. And with this, I'm leaving you here. You can reach us at mindhacking.org. I'm Eulenher on Twitter, and this right here is Mochtu, who will be at the conference, and, well, thanks.
Wow, I'm actually ridiculously impressed at how awesome these are. Okay. TLD. Top level domains, are you guys here? Nope. Moving right along. Okay, no, that's not it. Low-cost distributed direction finding. Okay. Oh, you were going to use your own laptop, right? Sure. Okay. I'll keep you honest.
You can.
Oh, okay. Okay. All right. Sorry. No worries. It's all shot, right?
My name is Zunkworks.
Actually, can we just do, just so that we avoid some problems from last time, just do a quick sound check?
Sound check.
Yeah, just say. Mary had a little-
Test 1 2. Test 1 2.
Is that
Thanks.
okay? Okay. Yeah, and then make sure to try to point it as much with your mouth as possible. Okay.
Okay.
Ready? If you're ready to go,
Okay.
then let's begin.
My talk is on sound card-based radio direction finding. Basically, what we're doing is locating transmitters and using simplified hardware that's cheap. And so what's radio direction finding? Determining the direction that a transmitter is relative to a particular receiver. If you have multiple stations, you can do triangulation. You can also do triangulation by making multiple observations. This is like a single receiver. So you're measuring the angle that the transmitter is relative to the receiver. With one station or one observation, you don't know exactly where they are, but you know what direction. If you have multiple observations or receivers, you can do triangulation and get a pretty good idea of where that transmitter is. There's a number of uses. Some of these are like emergency aid and rescue. Say someone's lost, but they have some sort of radio. You can probably help locate them. Locating jammers or interference of various sort. There's people that do tracking for sport or tracking wildlife, say endangered species that have been outfitted with transmitters. Finding interesting sources like police, perhaps, or military, and tracking them. Basically, this is your standard Doppler example. As you move towards a source, the radio waves compress and you get a higher frequency. If you move away, it's lower. So kind of an example here, normally the girls on the left are twirling, and as you're going towards and away from the horn, you notice a change in the pitch. And we're going to use this procedure to determine where they are. But instead of you moving around, you rotate your antenna. And if you know where the antenna is, and your received signal will have you'll have two signals. You have your antenna angle, and then you have your received signal, and you measure the phase angle, and that will tell you the angle relative to the receiver that the transmitter is. You do this a whole bunch and you average your measurements, and do some filtering. So basically, you have your antenna rotation signal, your Doppler shift, you run that into your sound card, measure the phase angle, do some DSP, GPS coordinates, triangulation, combine, plot, and coordinate with other stations or your own logs. Advantages, low-cost hardware. You can do updates on the fly. There's a lot of other things, other advantages that you can do by doing it this way. There are some problems. You do need a computer. Those are expensive. You could also do it on a microcontroller with the standalone DSP. Sound cards aren't the best analog to digital converters. They do have some error and problems, along with the way that it works with the operating system. This is a block diagram of what I've been working on using a microprocessor and a cellular telephone antenna switcher. They're pretty simple. You only have 2 bits to control which antenna you're on, and you switch between those quickly. You get a pseudo antenna rotation. Target computer is about $300, so we want this to be easily accessible. You do need a radio, however, at this time. Let's see. This is kind of an example of what a single station that's driving around and making multiple observations might look like. You can also do static stations. There's a pretty good book about implementing practical DSP systems by Richard G. Lyons. There's a good DSP intro course that's Creative Commons. If you're interested, contact me. I can send it to you. It was done last year at Tapper. This is the antenna switcher that I'm currently using. It's pretty small and very cheap. It's under $5 US for single quantities. And I'm just using a SparkFun breakout board to hook it up to the microprocessor and the antennas. This is the antenna setup that I'm currently using. It's pretty simple. It's made out of tape measures and PVC pipe. There's other variations that you could do, like 4 quarter wave whips. There are some problems if you were going after something that was sensitive, like police or something like that, and you were coordinating over the internet, and that you kind of expose your location in order to do the triangulation with other random people. There is a current working version that some Dutch guys built. I'd like to make an open source hardware and software implementation. Some more information, contact me via email. Thanks.
Okay, coming up next, we have Brain Hacks. Brain Hacks, are you here?
Brain Hacks is here.
Okay, what?
I'll send you an email.
Okay. One quick second.
All right, let me try and cheat a bit and skip over my first slide.
Oh, it's,
Oh, no, don't start it yet.
okay, no. If it's my screw up, it does, I don't start the clock yet.
Yeah, so my name is Manuel. I'm a cognitive neuroscientist working at the Synthetic, Perceptive, Emotive, and Cognitive Systems Group in Barcelona, which is a great place to be. However, my talk will feature stuff I did earlier at the Institute of Cognitive Science in Osnabrück, Germany, which is also a great place to be. Not as great as Barcelona, though.
Okay, so you ready to go? Are you ready? Okay, let's do it. Go.
Right, now that you know who I am, what am I going to talk about? Brain hacks. Well, what is a brain hack? A brain hack is just like a regular hack, just that it happens in the brain, which means you identify some neuronal mechanism that was evolutionary probably developed to do something else, and then you understand this mechanism, and you try and hijack or manipulate or exploit it to do something different, right? Now, brain hacks is not a new thing. Everybody does it, and the most prominent example are probably schools, right? The mechanism in question is learning. Now, learning isn't something that you do or don't do. It's something you do automatically. Your brain just sucks up information all the time. And school is the idea, well, let's just put the children into an environment where we control the input to this mechanism. Problem is, as brain hacks go, schools suck. They're really bad. They are ill-conceived, they are poorly implemented, they are crudely executed, they are inefficient. It's a bit like you found this car that just keeps magically going forward, and you want to steer it into your direction of your willing, but the best thing you can come up with is jumping on it and bashing the wheels with a huge sledgehammer until it turns into your direction. So the problem is, if we want to do a good brain hack, we have to understand the stuff. And if you Google for brain hacks, you get a lot of bullshit about brain improvement stuff, which doesn't explain you how it works. So I want to talk about hacking new qualitative experiences. Now, what are these? Philosophers call that qualia. And it's a bit difficult to explain if you're not into philosophy, but there's a very, very simple analogy. And if you look at this picture, now try to explain how this picture feels to a blind person. All right? It doesn't work. You can't. If you've never experienced something, then it's impossible just by different means to get the same sensation. Sensation is something that you have to directly experience immediately. You can imagine it, but to imagine it, you have to have this experience before. Or with the words of Louis Armstrong, well, if you gotta ask, you ain't never gonna know. Right, so qualitative experience is something magical, and for a long time it wasn't understood how these worked. And now we're trying to get a grip on it with a theory called sensorimotor contingencies. Now, what are these? Well, the classical model of how humans and robots and whatsoever work is a model called perceive, think, act, which is robot drives around and sees the world and sucks up all the information and builds a model of the world and thinks about, oh, what should I do next, and then acts. Now, this doesn't explain a lot of things, but it makes up for very beautiful diagrams, which is, I think, why it was popular in the 50s, because people loved arrays in the 50s. And it doesn't explain qualitative experiences and why you can figure out yourself, exercise to the reader. Now, think you're a submarine captain, right? And you're cruising around in the sea, and a vicious sea monster just plucks up all your cables and plugs them in differently. What do you do to regain control over your submarine? Well, you just have to pull every lever and push every button and see, what does it do? How does it change my sensor readings, right? And this is how you establish a sensorimotor contingency. You have to interact with the world. And you have to find out, if I do this, what will happen? And you have to find out what the lawful relations are. Okay, so it's about the statistical regularities about how you move in the world and how the world moves back. That has been identified as a key process in establishing qualitative experiences. Right, now that we know it, let's build a new one. Okay, where do we start? Well, we need a new way of interacting with the world. And what we are going to do is we are going to have a sense of north, just like pigeons do. And we build this by giving our subjects a belt equipped with an electron compass and loads of little vibrators around your waist. Now, what it does is it will buzz wherever north is. Where's north? Can anybody tell me? No. There. Okay, so it will buzz there, and as I turn around, the buzzing will turn around me as well. So subjects wear this for 6 weeks, all day long. And this is what the newest generation looks. So those little vibrators are now actually very cheap cell phone pager motors, and it's technically very sophisticated because it's all modular and does Bluetooth and whatsoever. But yeah, the basic idea is we do loads of tests before, and then people wear this belt for 6 weeks, and we do loads of tests after. And during the 6 weeks, they wear it all day long. Like they get up, put on the belt, and only put it up for down for taking a shower. So, now what kind of test do you want to do to see whether you actually have developed a new sensory motor contingency or a new modality, a new qualitative experience? As cognitive scientists, we're not just interested in the brain, we want to understand everything bottom up to the very top levels of understanding. So we're not just doing brain scans. Of course, we're doing brain scans because this is what we get money for, but we also do sleep EEG to monitor learning. We do nystagmography. If you don't know what it is, don't worry, I didn't know it before. We do lots of virtual reality experiments because we can manipulate the world. Some homing, like pathfinding tasks, space perception, and interviews. Now, I want to talk about interviews, which you might find surprising for a neuroscientist, but the problem is to explain the neuroscience data. I need more than 7 minutes, lots. Interviews are pretty simple because people tell you something, right? And now, what do they tell you? After wearing this bell for 6 weeks, they get a strange sense of expanded space. The space around them grows. How do you imagine that? Well, the space here is currently what I perceive as one consistent space, this room, right? If I had to point out to the coffee machine in the basement, I couldn't. No, it's you know, I have to think about how to go through there. It's somewhere there, but I don't know for sure. The space around these people grow to an extent where they can easily point out, well, this is there, and the Alexanderplatz station is there, however, the Dönerbude is a bit more there, and so on and so forth. So the space that they perceive as one grows. And this is what you can do with a relatively cheap setup, and I challenge you to build your own. Just go downstairs to the hardware hacking lab, grab an Arduino, hook up some pager motors. You don't need to use 30, you can use 10 or 20. Wear this belt for a week, 2 weeks, a day, 2 months. You will see something happening after 5 or 6 hours. Thank you very much.
So how many people noticed that I failed to advance one of those slides on time? One, okay, yeah, this is the presenter. Okay. So give him a round of applause for dealing with my screw up for that one, please. Okay, so we have coming up next, crowdflow.net. Are you here? Okay, cool.
Test checking, 1, 2.
Yeah, actually, and then just another thing, if you feel that you're going to be going back and forth or looking at the slides a little bit, are you comfortable using a handheld microphone?
Yeah, it's okay.
Okay, yeah, but be sure to keep it right by your, is that all right for you to feel, is he okay with the podium, or should we use a handheld from now on?
Can we test with the handheld?
Yeah, why not? Can we give him a handheld mic?
Which one?
Chantal, somebody? Okay, yeah, right there. Okay. Yeah, just give him a second to fade the podium mic. Oh, yeah, turn it on. It works better if you turn it on. Did you turn it on and turn it back off again? Okay, so 3 people in here watch the IT crowd.
Check, check. Check. 1, 2, 3, 4.
Okay, now look at your slide and talk.
Yeah.
Oh yeah, just like read your slide right now.
Crowdflow.net using Apple's location gate for research.
Okay, and then tell the audience they look beautiful today while looking at them.
Okay, thank you. So, my name is Michael, and...
Well, I didn't start your time yet. You ready?
Yeah.
Okay, go.
No. My name is Michael Krall, but you can just call me Michael. And, well, I started the project with the name crowdflow.net, and I will talk about it in a few seconds. Well, usually I make data visualization stuff for newspapers and websites and stuff like that. For example, this was the last project. I visualized some data from Facebook Is this 16 to 9? This looks a little bit strange. It doesn't matter. Okay, so Facebook data from Max Schrems. You can see it at Facebook versus Europe. We did it for TATS. And probably the most famous project was the data retention visualization on Site Online. I did it with Lorenz Matzat, and we visualized the, well, telecommunication provider data from a guy called Malte Spitz. And it's really interesting to analyze it, but it would be more interesting to analyze the whole society if you can see the pattern of the whole society. And there was this location gate thingy. You probably remember the iPhone tracker that you can install a small application that extracts the location data from your iPhone and presented it in a map, and you can see how you move through Germany. And basically it's working that the iPhones are scanning Wi-Fi stations nearby, measuring signal strength and stuff like that, and sending it to Apple. And Apple generates a map of Wi-Fi stations all over the world. And it then sends this data to iPhones, and these iPhones using the location of the Wi-Fi station to triangulate their own position. So it's basically like GPS, but it's called WPS. It's a Wi-Fi positioning system. And it's cheaper, easier, faster than GPS, and using less battery and stuff like that. So we started this project, crowdflow.net, and basically it's a Java app that can extract the data, the location data from your iPhone, and you can see it for yourself. It's a simple CSV file, but you can also upload it to us. And currently we collected 1,500 data donations. And we made some analysis and some visualizations out of that. The first one is where does all these stuff come from? So mostly it's from Europe, big part United States. Of course, Germany is pretty big because it started here in Berlin. And you can do a lot of stuff, or a lot more stuff. For example, 150,000 Wi-Fi stations are here in Germany, and you can use the MAC address to find out who's the manufacturer of these Wi-Fi stations. And you can make a chart, and you can see that AVM, it's the manufacturer of the Fritzbox, it's a DSL Wi-Fi station, is most popular, Arcadine, Cisco, D-Link, Netgear. This is a map of Wi-Fi stations in Berlin. I don't know how much it is, but probably a million. No, I'm not sure. Currently we have 30 million Wi-Fi stations. You can download it. It's a 1.5 gigabyte file. You can download all the stuff on crowdflow.net. But today I want to show you a new bug we found in this. First, that's really great. It's a mesmerizing video. I called it Firefly because it looks like 900 fireflies moving through Middle Europe in. And it's a time-lapse video, and it's in HD on YouTube. You should definitely see it. It's great stuff. But now here's the actual bug I want to show you. This is a small town in Brandenburg. It's Neuruppin. Yeah, probably never heard of it. And I added some dots for every Wi-Fi station in Neuruppin, according to Apple, where these Wi-Fi stations should be. And the interesting thing is that the Wi-Fi stations are distributed, and somehow there are some apartments and some buildings and estates where it seems to have 5 or up to 10 Wi-Fi stations. So why would somebody install 10 Wi-Fi stations at home? And these small clusters seems only to be in villages with a low density of iPhone and Wi-Fi. So it seems to be a bug on Apple's side. So I investigated it in a village, and I found out that these are the places where people live who have an iPhone. So why is that? Well, the reason is that the iPhone's collecting data about the Wi-Fi stations nearby and sends it to Apple. And Apple uses this data to triangulate these Wi-Fi stations to create this map. But if you have just one iPhone and you want to triangulate the Wi-Fi stations nearby, then, well, if you just watch it from one point of view, you can't triangulate it. So the best estimate would be that all Wi-Fi stations are just very close together. So that means that at places with just one iPhone, it started to, drag and pull all the Wi-Fi stations, at least the locations, to such small clusters. And, since Apple is still publishing the data, you can use this map well, to check if in a village is somebody living with an iPhone. Well, it's a funny thing, because I don't think that Apple actually thought about publishing a map of iPhone users. Well, during this work, I had a very interesting question, because every data that Apple publishes is anonymized. You don't know which iPhone, you don't know which Wi-Fi station, or will at least to whom it belongs, but still anonymized data still contains personal identifiable informations. Yeah, because you don't know which iPhone it was or which Wi-Fi station, but you can see that clusters are at the specific addresses, at specific houses. Well, I think you should think about it, what data privacy and data protection really means and how you can enforce it or not. Thank you very much. If you have questions.
All right, art hacks. And I think you left the I left the party before you did, and you did your slides last night. That I think deserves a heroic effort. So give him a round of applause for.
Actually finished up like 10 minutes ago.
Wait, when did you finish your slides? Did you email them to me?
Yeah, they should, like literally 10 minutes ago when I finished them.
13 minutes ago.
13 minutes ago, there we go. Should I use this microphone?
Yeah, what seems to be working better, the podium mics or the handheld mics? How many for podium mics? How many for handheld mics? Okay. Yeah, it doesn't really matter what the presenter wants, it's what the audience wants. So is this the presentation you finished 13 minutes ago?
It's horrible. It's going to be awesome though.
So you actually had the opportunity to practice it twice, right?
Sure.
I'll just say I set you up for that one. Are you ready to go?
All right.
Let's do it.
Okay, so this is Art Hacks Everywhere. I'm David Huerta. I'm one of the organizers for something called Art Hack Day in New York City, which is coming up in January. I'll go into that detail. New York City has recently had a very proliferant hackathon culture. So there's a growing technology community, startup community that has been putting a focus on, I guess, people building things. This is my first hackathon that I attended when I moved to New York City, called reinventnyc.gov. It's actually a hackathon that was sponsored by the New York City government, which is really cool. It also meant they had a decent sized budget, which is why we're eating like catered fish and not like old pizza. This is basically what a lot of them are like. But we want to do Art Hack Day, which is artists and hackers. This pretty much sums up why. At least half of it. And that's the other half. So in this case, we want to create epic things, do epic shit. So that happens when you have people with strong right brains and strong left brains working together. Or it could be really awful. There's really no way to gauge that until it actually happens, so we're going to do it. This is our logo, Art Hack Day. Nothing can go wrong. It's a very different type of event. We are taking a different approach to hackathons than other hackathons are doing, we think, because we're defining and broadening a lot of definitions of things. A little bit of background. This is Olaf. He's probably one of the main founder of Art Hack Day. He's actually based in San Francisco, but he commutes a lot to everywhere else in the world, including New York. Me and him actually made this like ridiculous scary pumpkin mask with the mohawk made of stems at NYC Resistor. And that's Paul. I could not find a real photo of him ever anywhere. But yeah, so he is basically the other organizer of this, the other like third of our little triad. He's a web developer. He does cool stuff. So it's for artists and hackers. Our slogan is basically, we're a hackathon for artists whose medium is technology and technologists whose medium is art. This is a technologist whose medium is art. So these are little turtle shell racers. They're pretty awesome. That's the sort of thing we want to see, because it's really cool. And of course, artists whose medium is technology. This was actually at the Museum of Modern Art down the street over at the MoMA. Basically, it's a showcase of sort of like interactive, human-to-object relations, which we thought was really cool. And in this case, this is something that we looked at before we started. Like I said, we're defining things very broadly. Warhol actually said that art is what you can get away with what you can get away with. So that's basically what we define an artist as. It's very, very, very open-ended, probably dangerously open-ended. We also have a broad definition of what a hacker is. In this case, people tend to spend way too much time on the semantics of that, in my opinion. But so basically, yeah, if you show up, congratulations, you're a hacker. So we have a few different aspects to the hacking that's going to happen. So we're going to have hardware hacking. Sparkfun has been very generous in donating a lot of really nice stuff to play with while we're at the event that is going to be given away to attendants. There's a very horribly named startup called Fascism, F-A-S-H-I-S-M, that's an iPhone app that's letting us borrow some sewing machines. So we'll be able to do wearable things, like this really cool EL wire outfit that somebody was showing off at the Robot Film Festival. MakerBot is also going to be there, of course, with MakerBots. So we'll be able to do some 3D printing, 3D design, and being able to build stuff on the spot. The venue itself is also going to have a laser cutter theoretically. So we'll basically have a pop-up hackerspace in the middle of Bushwick in Brooklyn. Of course, there's code. There's always code. So a lot of people that have a sort of history in data visualization are going to be there, from what I understand, that have signed up anyway. So there will be plenty of sort of the traditional get down on your laptop and start coding stuff out sort of mentality you see in hackathons. And then you have 24 hours to do it. Basically, the founders and I sort of have this philosophy that artists ship. So if you can't make art in 24 hours, you're not a real artist. So actually, we do have some restrictions on the definition of artist. But yeah, so it's basically, it starts in the evening, goes on well over into the next day. People have sleeping bags, etc. And then it opens up with an art gallery opening at the event itself, which is an art gallery, so it makes sense. This is different from most hackathons in the sense that most hackathons end with some kind of big contest. And we wanted to diverge from that a little bit and have more of a spirit of cooperation in terms of people working together to do stuff, so we just ended it that way. There's a location at 319 Shoals. It's really great to find places like this because they're spacious, and they have a history of doing cool stuff. They were also the sponsors of the Bent Festival, which is a circuit bending festival in New York. And that is a dead drop. So that is a sign that you found the place that hackers are invited to. We also have several sponsors. It's helping pay for the events. In this case, we don't focus on them too much. They're helping us out with paying for food, for building out the wireless infrastructure at the space, which is very art gallery-esque, meaning that the 10th person that signs on drops the internet connection. And we're measuring the success on this by how well people enjoy it, and then whether people enjoy it enough to spread it out to the rest of the world. So it'd be really awesome if there was an art hack day in Berlin, I think. So I'll leave you with that thought, and that's my time.
Okay, let's see, up next. grep for There Is Much to Find in Python. Python talk, are you here? Okay, well Python doesn't appear to be here, so we're going to take a quick break. Just because we have some last-minute presentations that are in my inbox, how about we meet back here at 2 o'clock? Does that sound good? Okay, everybody, give a huge round of applause to all the presenters. That was awesome. That turned out way better than I thought it would. Okay. Are you going to advance? Okay. Robin?
Yes.
That's me.
Okay. Are you going to advance your slides on a 20-second schedule? Do you have 20 slides?
Some kind of animation. I tried to expand it. I got 14, but it's also
Okay. I'll just put you in after 14:21 then. Okay. All right. Okay, all right. Yeah, no, that's good advice. Thank you. Yeah. Yeah, no, you're first after the break. So yeah, so at 2 o'clock, come back and you're on. Yeah, yeah. I know Lassie has time for questions in his, but very, very short. Yeah, I think Lassie's is good. Is Chantal still with here? Did she just, okay, good. Oh, I just wondering if you're still here. Okay, yeah, so Lassie's first after the break at 2 o'clock, and then I think that's it. Yeah, tomorrow. If you go to the wiki, it's just, no, I actually have to schedule it. So just basically go to the wiki, type in lightning in the search box, and then that brings up the Lightning Talks page. And so registration, basically you submit an email with all of this information to me at 28c3@nickfar.org, and including your slides. Tomorrow's an open round, so it's just however you want to do it. Just submit all of that information, attach slides. Yeah, I mean you have 5 minutes, but however you want to use that 5 minutes is up to you. No, you can. Yeah, no slides. Yeah. 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 Probably 2 hours beforehand, but yes, I will get back to you. Thank you. Okay. Yeah. Yeah, he's going to have questions, but I think, yep, Lassie does actually have questions for his presentation, and Chantal has the question mic. So if you think you're going to ask a question right around minute 4, just raise your hand so that he can be prepared for you, because he's going to have, I think, 60 seconds for questions, if I remember reading your slides correctly.
Sometimes like something like that.
Okay.
Okay. Microphone working, nice.
Yeah, just do a quick sound check, like say Mary Had a Little Lamb or something like that.
I think it's okay. Or
Sound
last
guy?
row, can you hear me? What? Wake up, please, last row. What? Can you hear me? Huh? The last row?
Oh, not the first row.
I hate to say this, dude, but I think you're being trolled.
I know. I don't listen to him, but the last row still says nothing. Can you hear me back there? Oh, yeah, cool.
Okay. Yeah, they're still asleep. That's why they're in the last row. That's how this works on day 3. Alrighty, Lassie, ready to go?
Okay, yeah, I'm
Let's
ready.
go.
Yeah, first I start with that slide. Nick asked me, I think yesterday, would you like to, or day before, would you like to pecha kucha? And I said, what the fuck? Yeah, I do. What's that? Yeah, first time for me. I just try it. Yeah, I think I started today at like 10 to make all the slides. Yeah, it will work out. Yeah, I'm talking about the ultimate file sharing network. A little idea I had months before, it's just a thing in my head. Yeah, and I want to think with you about it. Maybe it's good. Yeah, so the situation we are facing is the number of users bring numbers of servers to any event, and we have lots of files on lots of servers. And yeah, that raises many problems. And yeah, you know, when you look for all the FTP servers here, what is where, and the problem is, what is that file? Is it name correct, or is it that movie or that one? And is it really named right, or is it spelled wrong, or what's in it? All problems that we have. Yeah, and then, yeah, FTP. Yeah, I don't know how much of you download stuff here, but user limit reached. Maybe you know it. Maybe you've downloaded broken folder mirrors. It's a pain in the ass, and yeah, all the problems that arise. Yeah, what you find there on the servers, it's just sometimes random. Some people put their 720 movies into HD, and some say, no, that's not HD, that's too small. And yeah, the problem is movie, video, film, it's totally confused. Yeah, and the idea is we need to label our stuff, and then we need to distribute our stuff and can search it, and it all runs via torrent. So that's basically the idea for the ultimate file sharing network. And the point behind is the first thing we have to do is to label our stuff, and there we need to use only a list of allowed tags. We can't use any tags that we want because then it gets confused. And maybe use categories, so hierarchy. Yeah, and when we have labeled it, then we create a torrent and share it, and then we can index it and search it. And yeah, maybe with a fancy web application, maybe only with the console. Some of us still use that. Yeah, and after that we share the file, and I think there's only one good option, and that's torrent. Where you see why there. FTP just sucks on this big event here, and yeah. One of the points why torrent is so great in my eyes is it just spreads the bandwidth for all of us equally, and we have a constancy over any number of events. So a server that's now here will meet you again maybe at the Easter hack or something like that. Yeah, and is it? Yeah, and then we have the big questions. Now we have chaos. Should we use order system? Is it more productive or not? I don't know. Let's talk about it. And so the point is now, do you think it's a good idea? And the question is, will there be users using it? Because it's harder. You need to label the stuff, and you need to do work before you download something. Are there developers that help us? Yeah, that's all the questions. And the possibilities we have with it, it's fire and forget system. Torrent is either done or not done. There's not something, a folder that you don't know if it's downloaded correctly or not. It's there or not, and we can use it anywhere. Yeah, the question is, who likes the idea? Just raise your hands. Who would use it? And who will work on it? No hand? Okay, maybe you will come to me later or something like that. Yeah, there's a lot of room for improvement, and that's not the ideal solution. There are maybe better solutions, I think, but we need to work on it. Yeah, and that's the point. It was just idea in my head, and said, there's a problem, I download something, I have folders there where stuff in it I don't know, I haven't looked at it. And I thought, let's change something there, let's do something. What do you think about it? Anyone have a question? Yeah. Why torrent? It's simple. What's the alternative you think about?
Yeah, I'm just like asking why torrent, because torrent is like just for one file. So you have like one file, and the DHT is just like distributed for one file.
Haven't you ever seen torrents with more than one file in it?
Yeah, no, I agree you, but what I mean is like, for example, you want to download, I don't know, the last movies, fashion, American stupidity. It's very easy because there is plenty. You want to find something that is a little bit underground, you won't find anything because nobody distributes it anymore.
Yeah, it's mostly for distribution on an event like here. When you look at our servers, it's there, and there's not the point that you don't distribute it anymore. I think there's no alternative to torrent. 3, 2, 1. Yeah. Anybody wants to help me? Come.
Give him another round of applause for dealing with the bum mic. And then next up, okay. Sorry about that. Next up, we have, yep, zero-day press, or zero-day press release. No, no, you're second to last. Zero-day press release. Zero-day press release? Nope. Then broken lifts. Okay. Yeah. No, were the people who between when we started this morning and yesterday's lightning talks shifted this table over maybe 2 meters. So I couldn't plug in my computer over there, and the guy who borrowed my laptop, or who borrowed my VGA extension cable, who I said I was going to need for tomorrow, but absolutely insisted he needed for his workshop today, which led to another 10-minute crisis, which can I give a round of applause for Chantal, who found a 20-foot VGA cable on 5 minutes notice. Okay, so without any further ado, you ready to go?
Check.
Oh.
It's on. One, two, three. Can you hear me? In the last row? Good.
Okay, so whenever you're ready to go, let's begin.
Hi, my name is Toby, and if you don't like my talk, you're free to throw your rockets onto me, because I didn't get one. So I'm gonna talk about broken lifts, which is a project which was initiated by Raoul Krauthagen, which is on the next slide, Krauthausen. And he's maybe well known by weirmap.org. And yeah, there's a community called Sozialhelden. And that's when he announced the topic and created broken lifts. And that was in December, and at the Random Hacks of Kindness event. And there were many people involved, as you can see. And I'm going to tell you what we did. You can see that that was totally messed up with people who didn't know each other before. And we tried to create a better version of out-of-service notices for broken lifts here in Berlin. And the current situation is that you have the S-Bahn and the BVG as the public service provider. And whenever a lift is broken, you can go to this website and look it up. And maybe you noticed this on the top. S-Bahn puts the current date. So I prepared that slide at 4 o'clock this night. So what we came up with is this architecture, basically, within 12 hours. And so we just took the information from the website, scraped it, created an backend API to put out JSON and XML. And then there were some guys who created the front end, as you could see here, maybe. And so we came up with two versions. As I said, XML and JSON. We decided on JSON. And the backend could be called by different URLs, like seen here. So you could ask for lifts or stations or manufacturers, whatever you like. And that was one group, separated, developing on this. And so that's how it looks like. It's just a JSON file or an XML file. And there's a URL. You could just try it out if you want. And for the front end, we decided to build a static web page working with HTML, CSS, and JavaScript to load information. So we have a list of all the broken lifts and a detail view. And there are some statistics because we're keeping the history of brokenness. And that allows people to view if this lift is broken all day, so you won't go there anymore. And for convenience, you could track a certain route. So if you decide to go to Alexanderplatz and Friedrichstraße all week, that's an URL you could use all the time because it includes the IDs of the lifts. And so that's something that hasn't been on the websites of BVG or S-Bahn. What's the next slide? I forgot. Yeah, we used Ruby on Rails, and if you're familiar with that, you could just jump in. It's all on GitHub, and also if you're a front-end guy or just want to make design, we're looking for you. And you could contact us via Twitter or just fork the GitHub project. It's all open source. You could also try and take a look at it and just learn from it, because I didn't know all the stuff before. I never did a project like this. And we need you. We need back-end, front-end designer. You can also spread the word. Give us a tweet. And we want to improve the whole broken lift situation. And yeah, if you extend this project, that would be good. And yeah, are there any questions, please? I guess there are not. So that's why I put this slide in. That's just eye candy. That's a project visualization by Gauss. So that's how we created the structure of the project. And I just put it in tonight at 5 o'clock because I didn't know how to fill 20 slides. And that's where I finish.
I'm sorry, I got to ride this one out. It's part of the format. Because you see, I know that there's going to be somebody who's going to watch the videos of this and then see how accurate I was at clicking and advancing every slide and come up with an error vector for each one. So yeah, 5, 4, 3. All right, give him a round of applause. That was awesome. Thank you. Okay, the next talk is... Okay, Waz, are you here? Yeah? Okay, yeah, why don't we go ahead and swap over? Okay, now I'm going to try to keep you honest here. Yeah, that's probably better.
Okay, there's an alt tab to show the software working.
Okay, Ellen. Do.
It's okay, I only go 14.
Okay.
Oh, we're good? We're good? We are good. Test? Okay. Right, I've only got 14 slides anyway, so I'm going to start talking about a piece of software that I wrote. It's actually pretty simple, because it's a rubbishy computer. Donations accepted. Yeah, F5. It's not showing up. Okay, it's already there, yeah. Okay, good. All right, it's Wikipedia Plus.
Hold up, time. We're really professional today. Okay, ready?
Except for the equipment.
Okay. All right, on three. 1, 2, 3, go.
So it proceeds from the starting point that Wikipedia is a very good beginning for research, but there are problems with it. It's a popular attack target. Wikiscanner showed that certain people would like you to think that what's on Wikipedia is the whole truth. And Wikipedia decides we want reliable sources, so that's newspapers, television. That's good. If you control the newspapers and the television, you control Wikipedia. Click on the picture. Here's an example. Wikipedia says, oh, it collapsed due to fire at 5:21. I would say at least that there's room for discussion, but according to Wikipedia, there's no room for discussion. So how do you fit the discussion in? Because Wikipedia is a site that everybody goes to. So what the software does is you install it, you forget it, and then one day, hey, you remember it because it pops up a little suggestion. It's, oh, by the way, there is another opinion here. Click here for somebody else's thoughts about what happened to 7 World Trade Center. So that's what it does. How does it work behind the scenes? It's quietly, every time you're on Wikipedia, it goes away and it checks against the sites which you said you were interested to know about. Oh, do you know anything about this page? And according to, if it finds one, then it pops up a little button so that you can go there. So it's like, it's adding a little list to the, you might want to go here on the bottom of Wikipedia page, but it's not on Wikipedia, so they can't take it off Wikipedia. So it intercepts the page loads and says, okay, that's the language and that's the page name. Is there an English language site that you've said you're interested in that references this page name? So yes, you have to, it can only go to a site that's ready to receive it because you say, okay, this is my access URL, it's a template. He was on the 7 World Trade Center page. So if that's got a page, it will look like this. So it just sends out a head request, have you got a page? Checks the code, if it's a 404, don't bother. Like if there is a page that matches that, it's like, oh, by the way, here's a page that matches that you might be interested in. So how do you get your website ready for this? You choose an access URL. So if you're in a wiki, you might want to dedicate a separate namespace. Okay, this is just incoming access points for people who are using this. You have to include a page name because that's how you vary the access points, and then you send that to one of your existing pages. You may include a language code if you've got a multi-language website. Then you go ahead and you make the pages. So every page on your website has to be associated with one particular Wikipedia access point. So if you've got a wiki, that could be just a redirect. If you've got another website, you manage that how you like. I've written a little piece of software, you can just put it in XML. So are you locked into particular websites? No, there's a GUI. You can say, okay, these are the access URLs I'm interested in. So if you enable your website, and I say, okay, let's add that to the default install. If you want to configure yours in another way, you say, I'm not interested in that one, you just delete that. So yeah, you choose the sites. And what are you doing here? You're tying your website to a particular Wikipedia page. Now, okay, that does take some time, but it's got some value anyway because it's effectively a URI, which Wikipedia, you know, there's a lot. They're pretty comprehensive. They're fairly self-documenting. Just go to the web page. They're easily localized because there's a big list of foreign languages along the side. So you are getting your site ready for a semantic web. Okay, where is the software at the moment? There is a plugin that works for Firefox 3 or more. And what we're looking for is anybody who wants to develop it for IE or Chrome or improve the plugin, or even better, if you've got a website. That's actually the biggest gap because there's a network problem here. So people say, oh, but that only works for a couple of websites. Well, that's up to you. If you've got a website and you'd like some more traffic, then you just match your web pages to the Wikipedia URIs, and then you let me know via email. And there was some contact details somewhere. But you can probably remember the website anyway, wikipediaplus.org. And you could see it going, but I mean, that's no great shakes. Have we got time?
Yeah.
Okay. So you're here. You can enable it or disable it. It does slow it down slightly because I haven't coded it as well as it could be coded, I'm sure of that. But if you enable it, I mean, in Bangladesh, it's a right pain, I tell you, but you've got some pretty good bandwidth here. So, okay, it's popped up, a little thing. Then it's like, oh, you might wish to go here or here. Click here. You can configure it. It'll send you there, or it'll open it in a new tag or whatever. So there's a little bit of configuration you can do, and yeah, that's something else. And yeah, you know, are you interested in this website? Well, that's one that it comes with by default because I liked it. But if you have a website and you'd like yours to be packaged in on the list of default websites it could go to, then yeah, Wikipedia enable it and contact me. Thank you. Any questions?
Nope, I think that's it.
That's it. Okay, thanks.
Thank you. So, Waz, are you in the audience yet? Okay, if not, then buying Tempelhof Airport. You might as well go while we're waiting for Waz. Now, I have to admit, this guy is kind of legendary for having the weirdest lightning talk presentation ever. And I have actually made him structure his presentation into 20 slides. So give him a round of applause for doing that early this morning. So, nope, not that one. Okay, we have the timer set. Oh, do you want to use the handheld?
No, Hi.
And ready to go, 1, 2, 3, go.
I decided to buy the airport Tempelhof, and only I have these laughing keys. And I offer 1 key for €1 to buy the airport Tempelhof. You see it here in the picture. This is the airport. That's also the reason why the laughing comes into the key. Why I want to do this? I want to build a temple machine. It's a movable machine to rock a party inside. 365 days. And yeah. This is a Verdichterhaus. There I lived for 3 years, and there I get the idea of a fire machine, temple machine, and I lived there for 3 years to build this machine. It's a nice location and place to be. You see it from above. Inside my living room for 3 years, there I built the machine, a small model, only 6 meters high. And there I give the keys to the people that comes to rock a party there inside. And it was really good. So, and I tried to build there, to make there a party with €100,000, and it didn't work. And after this, I put in a party for €1 million into the internet. This is the machine inside. It's all movable. I have also videos. You can see it. Just Google Temple Maschine, and you can see the videos. It's 12 meters high, 48 meters around, and so it looks inside. You can put it also at other places. The machines are connected together in all continents. I want to build a machine, and Tempelhof is the location for all temple machines worldwide. Yes. So it looks at the Tempelhofer field. Check. So this is near the airport reference point. There should the machine then stay, and the party rocks there the whole year, 365 days. Also in the winter, there are heaters infrared heaters, you can dance there with a shirt then in the winter, open air. This costs a lot of energy and also a lot of money. And the shortest way to buy an airport is offer one laughing key. It's art for me. I have only keys. For 1 gigabyte, this is 1 billion euro, and ask 1,000 of the billionaires worldwide to buy this key. So we can rock 365 days, 8,760 hours, and dance. So, dance now. So, that's the reason I do this. I want to know one place in the world where the people every time are dancing. Every time. And then we teleport us from one machine to the other. They are connected with beamers and other geeky stuff with 3D mapping. And we see us, each other, dancing in Tokyo, for example, or in New Delhi, India. So that's it. We need also 1,024 millionaires that pay only a deposit for a key. I don't sell the keys for 1 million. You can only pay a deposit for this key that we get also 1 gigabyte euro. So tell all millionaires you know, I have laughing keys and 1,024 of them, so many keys. In 8 units, 128 every 3 months. I want to fill them up this year and next year. We have worldwide 10 million millionaires, 10 million, and we need only 1,000 of the 1,024 of the 10 million millionaires that pay a deposit for a key. And they get then a laughing key in 1 ounce gold after 1 year. And yeah, after 1 year they get also the key and the money back. We need only the interest of the deposit. These are the people that we have to ask. So we have 1 million euro a week for the party. And we can build in a lot of geeky stuff and rock the party for free for everybody who comes there. Tell it all billionaires and millionaires, you know. And we see us then dancing in the machine and my new airport, Tempelhof, here in Berlin. The town Berlin don't know what I'm doing, but when they get the money, they will be really happy because they need it here in Berlin. Yeah, that's it. If everybody want a key, come then to me in the machine. And next year I bring again some stickers.
Okay.
No question? No question.
Oh, no time for
Really?
questions.
Perfect.
Give him a round of applause. Waz, you're up next. Yeah.
Guten Tag. My name is Amanda Wozniak. I'm an electrical engineer, and no.
Hold up. We actually take pauses and breaks for things. Remember, we're in a socialist country.
Always be ready to step up.
Yep. And I spent way too much. I apologize for breaking character a little bit in that last one, but they were saying some funny things in IRC. Okay. So, and let me just double check. I think we skipped some people who might not have been here. No, we're good. And I think this is the last one of the day because we had a couple of cancellations. So you're familiar with the pecha kucha? Oh. Harvesting boarding passes, I think, did you pecha kucha-tize you did? Did you email it to me? Okay, we'll figure that out. We've actually got time to figure that out after Waz's talk, but I'm going to get her going and then we'll talk about it, okay? Alrighty, so the pecha kucha format, quickly for those of you who just joined us in the streams after hearing about the last lightning talk, is 20 slides, 20 seconds per slide. They auto-advance, and that is about it. When we're running out of time, I'm going to go
5, 4, 3, 2, 1.
and that means you're out of time. And if you build question time, you didn't build question time into your presentation, did you? No?
No,
Okay.
because it's a little longer,
Okay.
because I need to click through faster sometimes.
Okay. But it's 20 slides, though, right?
No,
How many slides is it?
I think it's 26.
26? Okay. Well, then,
Some slides should only be
oh.
5-second slides.
Microphone, because IRC can't hear what you're
Some
saying.
slides should only be 5-second slides,
Okay.
so. click.
Well, I don't know. Should we allow it? All right. Okay. How many people say we should not allow it? How many people want to let her get away with it? Okay, you win.
Yay! You get more information.
Okay, all right. That's my screw up. So normally during lightning talks and I screw up, we add time. So it all works. You've got 6 minutes and 40 seconds, and just say slide when I need to advance.
All
Okay?
right.
And that includes this title side. So
Okay.
1, 2, 3, go.
All right, so open sourcing the engineering design process. Basically, I'm a double E, and I'm going to talk about everything that goes into building an electrical system that you should think about documenting. Slide. All right, so first, what is the engineering design process? It's the miracle that occurs between when you have an idea and when you try to get hardware. And it's a miracle because depending on what you're making, it can be incredibly complicated. If it's a mechanical system, a code system, there's a lot that goes in there. Slide. So, you know, the idea, okay, well, I'll just talk about what I did, but it's really hard based on what you're building. You can have design for manufacturing rules, you can have schematics and bombs, but there's a lot of other things you might contemplate when you're building a system. Slide. So convention states that if you're doing open source hardware, a schematic and a BOM and a Gerber is sufficient to reproduce your design. It's like an executable file. Should that be sufficient documentation? And the answer is no. Do you know what this board does? If I gave you the parts list, how long would it take you to figure it out? Slide. Because there's nothing open about your hardware if I have to reverse engineer it in order to improve on it. And it's the same thing for code if you don't have a documented code or if you had like a lot of contemplation about a protocol that went into you making a system. If you tell the story of your contemplation, then other people can actually like work with you in a dialogue to improve upon your project. And I'm going to run through briefly what we need to do for hardware in order to make that possible. Slide. So the industry beats hackers in hardware design exactly because when you're at a company behind the NDA and firewall, you're required to document everything about your product, including your rationale in every decision as you go. Their motivation is if they lose an engineer, they don't want to be able to lose, they don't want to lose the project. And you know, it's very, very strict how open things are so that you can have a very good review and a dialogue between generations of engineers and engineers across, across companies and across continents. Slide. So this is the vaulted engineering design process. It's literally what you do every day when you're messing around with a system, but you be formal about it. So you have an idea, and then you ask important questions about the system you want to build. Then you answer internally all of those questions, and this is what most people skip. They don't write down their rationale. They don't say, oh, I'm really trying to build this radio system, so I need to make these decisions. And so when they end up 2 years down the line, they don't remember why they chose to do something. Then another thing a lot of people skip is you need to hold a review. You need to invite other people who have not been there with you from the beginning to look at what you're doing and sanity check your stupid mistakes. Then a lot of other things we all usually skip. We try to go to the end and get a final product, but you really want to make one, test it, go through and do full test coverage. This is very important for hardware. It's also very important for secure software. And go through and see if you addressed your original questions, and then you make money and profit. Slide. So it's a real pain in the ass to go through a formal design process, but if you do it, it really, really saves your bacon because the cost of mistakes in hardware is a lot, yes, delicious bacon, but the cost of failure in hardware is you might have dropped 20 grand on a build and it comes back and you've got 500 boards that don't work. Slide. So the following are crib sheets that for the process that I follow when I go through and do engineering design, regardless if it's for work and prototype medical devices or the ninja badges or hobby projects. So read the details later on because we're going to go through it really quickly. Slide. So this is an example from work. I've given this talk before, so all of this is totally public, but I had a project where one of the faculty members wanted me to build an autonomous robot. And I say, okay, well, as an engineer, my process goal is to front-end load all of this design work and the effort so that I can debug this and reuse it trivially easy. I want to do the work now so that when I have to look at this project in 2 years, I don't need to do any work later. I want to be very, very lazy down the line. Slide. So every project begins with the motivating questions, and always, always do this. Why are you making it in the first place? Who's it for? How it will be used? What features are necessary? What features are bonuses? Are there legacy requirements for other systems? And really like how, and then the last questions are about manufacturing. Who's going to build this? Are you building it by hand? Do you have a budget to have someone build it out of house? How many do you need to make? And what's your timeline? Slide. So this is the hardware design workflow that's explicit to electrical engineering design. It's different from mechanical design. But the concepts are you actually review at your design concept level. Like when you have an idea, you make sure it's a good idea and you make sure it's worth doing. Then you do all of like the specific work for your CAD program from dealing with parts and the schematic and the layout. And that's like, it's like writing your code, it's like setting up your framework in a development environment. Then you have all of your manufacturing, that's the third part where you check based on who's making it, if you're doing all of the right things to make it easy for them to make sure that when your stuff comes back, it's what you thought you were building and it's correct. And there's a lot of detail in this. So it's very important to go through each step in a logical flow. Slide. So this is what I did for that like demo robot is I actually broke it down into modules and I'm like, what is already existing so that I can reuse it? Because if I have to redesign everything and be original every time I make something, I'm never going to get beyond a blinky light. So, you go through, and for hardware, you go through application notes and data sheets, old projects, cookbooks like Horowitz and Hill, off the shelf, and other things in the community, because someone else might have already built what you're looking to build, and you just need to put a little bit of an extension on it. And then to be rigorous, I break it down into block diagrams and look at the input-output relationships, much like you would if you had an input parser going to an operating system. Slide. So, even pros use Arduino. The take-home lesson at the bottom before going through the design rationale is final releases are what are optimized, but if your first point in a project is to build something that works, build something that works. Hardware is iterative, and you can always optimize later. So an Arduino is open source. Great, I can copy the files. The Mega had a really fast SPI bus, which was one of my requirements for this robot. I didn't have to waste any time on originality. The learning curve for the toolchain is null, and I thought, okay, maybe like other people have worked with these servos and I can piggyback on their code. I had to rewrite the library, but I thought I might have had a shortcut for being lazy. Slide. So going through the next bits, which get really into double E stuff, you want to Wikipedia these lexical definitions. I've grayed out, the definitions that you should read later. But a part library is the representation of physical parts in your CAD system. A schematic is the logical drawing of how you connect all this stuff. A layout is the software representation of how it physically looks as a circuit board. And tape out is the step where you're done doing all of your CAD cycling and double checking of everything on paper. And then you send it out for manufacturing and start to pray that it comes back right. Slide. So best practices when you're doing a schematic is start with your CAD library and curate your parts as you go. So as you pick parts from DigiKey to use in your design, make sure they're in your library, make sure they're correct. If you copy a library from like SparkFun, double check the footprint. I've never seen people commit stuff back. Take time to find multiple vendors. Take time to note physical design rules. Go.
3, 2,
1. Out of time?
Yeah.
Okay.
Sorry.
So, that's fine.
I really hate to say this, and this is me being completely selfish and circumventing the rules and being unfair. I actually kind of want to see like the rest of this.
It's really educational.
as opposed to the comedy that you're used to.
Right, exactly.
What's IRC saying?
Oh, IRC is loving this. They're all. Yeah, it's hilarious. So yeah, I'm gonna try to do the no nerds left behind thing. I'm gonna take a poll in IRC and take a poll out here. How many people want to see the rest of the talk? Okay, and then because there's actually a 30-second delay, gonna wait to see what IRC says. Okay, +1, +1, +1. Okay.
Okay.
Continue.
All right. I'll try to go faster, but I'm trying not to talk too quickly.
No, I think the ongoing gag on, oh, okay, now they're saying faster, but the
Faster,
ongoing,
oh.
okay, yeah, just go for it.
Okay, so from the previous slide, basically that you want to curate as you go and keep a list of every part you buy multiple parts. I'm not kidding. If a vendor sells out of a part and it's critical, you need to know how to replace it. And that means note what's critical about your parts. If you don't give a shit what value a resistor is, say that in your bill of materials that you keep private and release later. If it's very critical that an amplifier is like not subject to noise, write that down, because otherwise in 2 years, when you forget why you picked that amplifier, you're going to shoot yourself in the foot. Okay, so best practices for PCB prototype is all of those things have rules that go along with them. You should follow them in the layout and then just iterate until it works. Pre-tape out checklist. This is what you do before you pray. Go through and actually make sure that you fixed all the bugs that you're like, I'll fix that later. That's really annoying. Make sure that everything matches again between the PCB footprint for the part and what you are actually buying. Don't put MOSFETs in backwards. You have to jump over them with staples, and it's a bitch because staples are hard to solder. Make sure that all the pinouts are correct. Make sure that your schematic matches your prototype. Like, don't change things on the fly that you can't prove that they work. And then just go through and be very anal retentive about the layout. Your vendor will thank you, because otherwise they'll come back and say, I can't build this. What the fuck is your problem? Slide. So this is a fabrication package checklist. This is what you send to a manufacturer when you want them to build your design turnkey. You might say, well, I don't need this if I'm building it myself, but the answer is you do, because then when you forget, because you're cracked out after 48 hours of staying awake building things, you have your references here. You've written it down. You save yourself time. Next. So, and this is the design documentation checklist, and most of this you should have already generated during your process, and then it's just really easy to open up to other people so they can learn from your process. Both from the goals, the system block diagram. I literally do break everything down by that block diagram and have a paragraph in my user document about stuff. Did I do this for the Ninja badge? No, not yet, because I didn't do it before. And it's a year and a half later and it's still not done. Same thing with your software firmware summary and how a user should use it. So next. So you're like, are these things I should do or things you should talk about? The answer is both. Write down your rationale as you go along, and then that document generates itself, and then the next person can come and work with you. Because, slide, the predicate of read the fucking manual is write the fucking manual. And, slide, and documentation should be a dialogue. I should see that you made a really awesome RF widget or a near-field communication widget for this Android phone, and I should be able to be like, oh, hey, oh, he found out that like this part from this vendor is a piece of shit, and you should always use like the Freescale part. Oh, awesome, I'm never gonna like make that mistake again. So if you write the story and I write the story and we both put it out there, we can really build awesome systems. Slide. So the added benefits of openly discussing your process are, one, you seem less hardcore because everyone sees how much you mess up, but then you get to defeat things like analyst bias, where you assume that I'm perfect, or asshole bias, where you assume that you're perfect, or cargo cult bias, which is like what everyone does with radio. They say, oh, it's black magic. If I copy it exactly, it will work, not understanding any of the underlying process parameters of physics that might make it not work. Slide. So the real world example is that robotics controller I built. I've been able to hand the documentation and a kit off to a bunch of different people, and it's gone in things from microscopes to diagnostic machines and human-assisted robotic devices, and I've had to do maybe about 5 to 12 hours of extra work. It's wonderful. Slide. You know, it's the same thing whether or not you're doing it for a hobby or whether or not you're doing it for industry. This basic documentation, just you start to get into things like how does your stuff fail over time and temperature and in the field. And it's just a matter of details and complexity, but the form of the process and the form of what you want to document is always the same. Next. So the more you share and the more others can question your design and question your sanity when you're making something, the faster that we can all learn from our collective mistakes, and the sooner we can celebrate our collective successes and make much, much more excellent systems together. Thank you.
Yeah, wow, I was totally and utterly and completely impressed with that. Another round of applause for Waz, everybody. That was awesome. No, okay, we have one last presentation left. And yep, harvesting boarding passes. Andre, are you ready? Okay. And this is actually 20 slides. And you kind of failed because I did ask for a PDF in the directions, but we're going to let you get away with it anyway. Is that cool? Nope. Oh, crap. Shit. See, the first half of this lightning talk session went so well. The second half obviously had to have some massive fail in it, so I apologize for that. See, I hate to say it, but it's just that easy. Bam, okay. And then, all right. Reset.
Check. Okay.
Check. Yep. Oh, don't forget, try to hold the microphone as close to your face as possible. And just let's do a quick mic check. Just read that slide so that the
1, 2,
sound
3,
guy can adjust.
harvesting boarding passes, everybody in the back. Cool? No? Okay.
Okay. And go.
Okay, my name is Andre, and I'll be presenting harvesting boarding passes. So the idea came up to me when I was once doing some checking from hotel lobby workstation, and I was thinking like, hey, a lot of boarding passes should be floating around the internet, right? So I think everybody of you used these boarding passes, and most of you, or 100% of you, use online check-in and have digital boarding passes, right? To a certain degree on your mobiles, or usually as PDF formats, even though they sometimes replace you at the gate with things like this. So given the privacy concerns, so mobile tracking is like science fiction maybe, but something which is on the paper or on a PDF and floating around the internet can give a lot of details like about privacy stuff about you. And given the concern, people should be like more oriented towards securing their private details. And given the fact that everybody is like pushing now the online check-in process to minimize the operational costs and so on, and the convenience from hotels or home check-in, so this is becoming a big trend, and it's already a big trend of doing online check-in and digital format boarding passes. And what we can learn, we can basically learn, for example, a given traveler, what his airline preferences is, and what this can help us. We can estimate his budgeting, or we can estimate other things like what he likes to travel with. And the other things are, for example, the frequent travelers numbers. For example, WikiLeaks document mentions White House directive to gather frequent travelers of high-rank officials. So it's like a very interesting number to find on the boarding passes, because it's usually printed on the boarding pass. So frequent traveler number gives a lot of details and access to other things. Other details which you can, or intelligence gathering guys can extract is, for example, preferred hours of departure or coming back, and so they can learn scheduling of a specific person without doing standard surveillance. The other thing is like what routes usually a person exposed operates, and this includes like inbound, outbound connections on preferred routing all over the world, and usually it's not very random. And other things is like, given a set of boarding passes, you can actually see no matter where the person travels, he always comes back to a given location. So you can infer or deduct where the person lives currently or he is mostly based, right? So for example, in this case. Other random ideas is like reconstructing or predicting a track for a given person. So you have a target and you want to know where he'll be going. So having statistical data on him from boarding passes, you can actually predict or reconstruct a track to a certain degree of correctness. Or you can actually try to impersonate a given person by whatever means, checking in on the name of a target and impersonate the target as if he or she will be flying like that. Other things include, like, you can give them the ticket number or frequent traveler. You can do some check-in cancellation on various systems. It's not allowed on all the systems of online check-in, but it's still possible. You can, for example, do group check-in impersonation. It can be useful for private detective services. For example, if there's a group check-in of a person, male and female, they can deduct like marriage cheating cases and so on. So it's private details. People don't want these maybe leaked. Or poison the leaking. So basically use Google Docs, right? And I came up with a short list which actually people can contribute because there are plenty of airlines, plenty of systems. You just do a Google Doc search and you find lots of details on various file sharing or file hosting systems or blogs. So I've tried to summarize for KLM and Lufthansa, basically, and here are some lists. And on the next slide will be a longer list, but basically KLM and Lufthansa I see as big ones, so I've tried to target these ones. However, if you put some effort into getting the words, as you can see, they are very predictable because they are generated from various reporting systems. So these words, you can try to fuzz them and find various PDF documents with this internet check-in, boarding, or so on and so on. So you get a lot of results. The first takeaway is you have to secure your sensitive data or the sensitive data of your client or whoever you manage. And if you fail to do this, then you should not be winning around that somebody is tracking you, because in the first place, you're leaking your sensitive data in the first place, right? So this is one very important takeaway. Second is like try to contribute based on your online checking experience, contribute with Google Docs, because it can help others to check their own exposure, so to speak. And basically, the last takeaway is use it for your own testing. Don't stock on people, because first of all, it's illegal and it's harassing and so on and so on. So you understand the implication. And the idea is to just do it on your own details to make sure you're not exposed. And I think that's about it. This is the last slide. And I have, if there's a quick question, maybe. If not, somebody will be counting me now? Okay.
5, 4, 3, 2, 1.
Thank you.
All right, thank you, everybody. And I do want to give a extra special round of applause to the audio angels who had to keep up with all of the different changing levels for all of the presenters. This was the toughest audio angel job that you will have at Congress. Huge round of applause for that guy behind the board over there. And of course, the video angels, all the presenters. One last round of applause, guys. Thank you so much. We'll see you back here tomorrow at noon.